Hi guys, so here is a quick video on how to find the main function of a executable binary. So in our case we will take the example of Adobe Reader. So as we see that the symbols are loaded for this binary and a bunch of DLLs. So let's clear up the screen and we can list out the loaded modules, the LM command, and this is the entry point of the image file name. So the image file, the structure looks like this. So I have I've drawn some of those things. So the function entry point, the main function, even though it starts at the code segment, so but in executable has so many other segments. So there would be stack, and then there would be heap, global variables, static variables, and then the code segment. And every such process, the process block, this is in the virtual memory, it will have a copy of the kernel stack as well, every process. So because every process, so whenever it is loaded into the memory, so it would be run by at least one CPU core. So a CPU can have multiple core, or there could be multiple processors as well, and each one of them would have their own core. So at one time only one thread can run in a single core. So if you have two cores, so two threads will run in parallel, but for a single core only one thread will run. So that will have a copy of the kernel stack and the process stack. So this is like the process memory. So what WinDbg gives us here is this thing, or it would be any of these things. So if it doesn't find like stack or heap, so if we don't have anything, so it will give this thing. So it will be pointing here, but we need to reach to this thing. So to do that, what we use is we use the ex entry. So it will give the entry point of the program, and that's not the main function, it's just the entry point. So if we unassemble that or disassemble that, ex entry, so we get the entry point of that place, that the first whatever data is present, the instruction is present in that entry point. So we will use another tool. So it's IDA Pro, and we will see how that looks like in assembly in much more detail. Even though we can use WinDbg throughout, but in IDA it's much more appealing to the eye, and it's easy to visualize basically. So let's load this, and it's a PE file. So don't have any debug symbols for Adobe, of course, so will not bother. Now it will take a while to load all the binaries, so let's give it some time. Now one important thing we need to do as soon as this is fully loaded, as you can see towards left bottom, so it's loading some stuff and it's running some heuristics. So as you can see, so changes, the UI is being changed, so it's drawing those things and generating a very decent UI for us to analyze. So even though it looks like in front of us that WinMain 16, that's the main function, so that's how quickly IDA can find that. So you would notice that there are some things like this offset over here, the address, so it's different from what we have over here. So we will see that why that is the case. So IDA uses many heuristics and it is able to find the main function. So we will get to here, because not all the time we can get to the main function, doesn't happen all the time. So we'll check that as well. Okay, so in the exports we see that we have a start. So this is the graph view of IDA. So if you want to go to a place, you just double click it and you can see that some kind of branching is happening. So JZ is the branching instruction here. So I have covered these instructions in my assembly language tutorials. So jump if zero flag is set, or otherwise you go here. So those things. And to come back where you were, you have to hit escape. So suppose if I want to go to this, so I will just hit escape and I will come back. Okay. And if I hit space, so it will just show me the disassembly and not the graph view. So here this is the text segment, and what we have here is proc near, so this is a subroutine and stuff like that. So because of ASLR, the offset that we see here and the offset that we see in WinDbg are different, so we will rebase our image. So it's Adobe Reader, Adobe Acro RD32. So we will first rebase that. So it's always good to rebase because of ASLR. So you would be finding different address in different parts. So it would be hard to analyze. So the program will rebase itself. It will take a while, so that we will have a consistency. The address that we see in WinDbg, the same we will see here. Okay, so we get back to the graph view. So this is our start. Okay. So now we had already found this is our entry point. So we can press G and 0x and go to that location. I guess it is still processing, rebasing, so it should have ended by now. Okay, so we are here. So our rebasing is complete. So I don't know, I didn't get to see anything like rebasing is complete, but doesn't matter. So this is our start, and we are having this function like in its stack cookie. So that's actually this guy over here. So because it's the binary, this is the image, and inside that there would be this is the entry point, which is this one, and then there is an offset for that, so the total address would be this one. And these are all virtual addresses, they do not represent the actual physical address. Okay, so we will go back to the graph view, and we will see, let's see this guy. So this doesn't give us the main function. This is checking the stack cookie, so probably this is the only one left. So we are here, so we could take this branch or this branch. So if we take this branch, we'll come here and then here, and these blue lines are the loops, and the green ones are if the branch taken and if the branch not taken. So this is very easy to see, and then eventually we will find the main function. So this is our main function. So this is the standard, like in Windows we have like WinMain. So that would be the main function, and of course to validate that we could see so many other things like this is the standard way to call a Win32 API. And based on this, so it's highly probable that this is our main function. And if we go back here, we would see such things like H instance. So this is a very high indicator that this is a main function actually. So these are so many other variables, so that's the reason I told you that the image base could be pointing to this one instead of this. So we need to rebase and do those stuff. So for and more thing is this is like the preamble preamble code while creating calling a function. So this is the initial thing that runs, and this is a stack cookie, so this is for preventing the buffer overflows, the stack buffer overflows. Okay, so there you have it, and this is a very big chunk of things, and it's, if you have a bigger monitor, you could you know, it would be much easier to see that as well. Okay, so this is I wanted to cover up quickly, and I wanted to show you this. And let's go back to the debugger. Okay, so you could try this on different binaries and find the main function. Usually IDA would find that, and sometime if it doesn't, so you just have to look at the blocks like I did, and it will take a while, and you will be able to find the main function, and from there you could start your further analysis. And thank you for watching, and if you like this video, please subscribe. I will catch you in the next video. And I'm working on my another tutorial on operating systems, so there we talk more about like what a process is, what a thread is, and how the security aspects work. And you will get to learn things like, is it the entire binary which is loaded into the memory, or what's going on. So I will see you next time. Bye bye.